G'day, welcome to Downward Woodworks. In today's video, I'm going to be building another homemade workshop machine. This time it's a 12-inch disc sander. The motor for the disc sander is this one that's in my 14-inch bandsaw. I upgraded the bandsaw to a new mount and a faster motor. With the old motor out, I could start taking measurements for the body of the sander. I allowed for a 200mm deep table in front of the disc, measured how long the whole unit would be, and how high I needed to elevate the motor for the 12-inch disc. The whole unit, except for the table, will be made from 12mm MDF because I have quite a few sheets that I got for free. I started by cutting the base to size and then cut the two side pieces. On the side pieces, that lower section is the elevation of the motor base and the higher section is for the table. Apologies for the shaky camera here, I didn't realise this was happening as I'm finishing cutting the side pieces with the bandsaw. I then marked out the screw holes to attach the sides to the base. It's critical to drill pilot holes whenever screwing into the edge of MDF, and the optimal drill size I find is 1mm smaller than the screw. With one screw in place to stop the pieces moving, I drilled the rest of the pilot holes, and then the holes in the base plate were drilled as clearance holes and countersunk. I attached a couple of pieces to the inside of the side pieces for the motor support board. These were glued and clamped for now and then reinforced with screws later. For the disc itself, I roughly drew a 12-inch circle on two pieces of the MDF so I could cut off the corners before laminating the two pieces together to make it very solid and stop any flexing when pushing against the disc while sanding. I weighed it down on a flat surface and left it to dry overnight. At the router table, I made a very simple jig to route the circle shape to the final size. The jig is just held against the edge of the table with my body weight. How's that for dust collection? It's one of the best things about this homemade router table I built. I'll link to the build video below. I used the dowel to give me a centre for my compass so I could draw a circle to lay out the mounting holes to fix the disc to the pulley of the motor. first drilled pilot holes in the disc and then clamped the pulley in place and transferred those drilling locations onto the pulley. The pulley was made of cast iron, so it was pretty easy to drill. I started with a pilot hole and then drilled the holes out to the right size to be tapped with an 8mm thread. Then using the drill press to keep the tap perpendicular to the pulley surface, I tapped the holes, turning the chuck by hand. I used the taper tap first and then finished the threads off using the bottoming tap in the battery drill. On the disc I used the Forstner bit first to countersink the holes for the bolt heads and then drilled clearance holes for the bolts. I added some extra supports underneath the board for the motor to stop it from flexing, first just by gluing them in place, and then I came back and reinforced them with screws again. The motor mount was then glued in place and I added screws into those centre supports from underneath. Once that had set, the motor was bolted into place and I used an old chisel with a stop on it to true up the face of the disc. There was very little wobble in the disc, so it didn't need much taken off. Next part to make was the guard. I trimmed the board to size and then cut out a section to clear the pulley at the back. I then used a nut to trace out the top shape of the guard to provide a small gap of about 5mm. I added a couple of pieces to the back of the guard that would sit on the motor mount board and get screwed in place. I used a piece of 3mm MDF for the top of the guard by just bending it to shape and gluing, nailing and screwing it into place. I used melamine for the table because of its smooth and hard wearing surface, and as you can see it's just 2 layers for the table and a couple of side supports. the face of the disc came out perfectly smooth. Once I was happy with the disc and sure that it wouldn't need to be removed for any reason, I filled the holes for the bolt heads, otherwise they would have transferred through to the sanding surface. With the holes filled and sanded smooth and level, it was time to add the self-adhesive Velcro backing. This wasn't as hard as I imagined it was going to be, and that adhesive was so strong I could barely remove my fingers after touching it. And then on with the sanding pad. For the dust extraction, I had this PVC flange as the hose connector, but it wasn't quite long enough. So I extended it with a small length of pipe using Starbond medium thick CA glue and accelerator, which worked out perfectly. To keep the two pieces lined up while I glued them, I used a smaller piece of pipe with some oil on it so that it wouldn't get glued in place too, and then just pulled it out when the flange was set. I installed a front panel to seal off the dust enclosure and drilled out a hole in the side for the hose connector. A quick test run and I couldn't be happier. Very satisfying. Last thing to do was paint all the parts, which I did off camera, and then reassemble it and put it in its place.